Greetings. You've seen the electronics of my 10 gigahertz transverter, but you haven't seen the enclosure yet. So it's time to do a reveal. It's an ABS box. It's a gray box that I painted white. The painting job is not great. It's leftover paint that I had. It's got some flakes in it. It's really not great. But since it's going to be 40 feet up in the air, we're not going to see any difference. I put 3 coats. It's an exterior rust paint that I had, and it's going to do a good job. It stinks. I can't wait to bring it outdoors, but it's going to be watertight. Why painting the box? Well, the box is light gray, as you can see. So I decided to paint it white to reflect the sunlight as much as possible and keep the electronics inside as cool as possible. And that's the only reason why I painted it white. This is an ABS box. It would have lasted many years in our weather, but decided to paint it white. And I've already exposed that box to the sunlight, and I can tell you it makes quite a difference compared to other surfaces around. The fact that it's white or almost white. It's not the whitest white, but it still works fine. It's a glossy paint, so that helps even more. So yes, it's an ABS box. Dimensions are 285 by 190 by 130, which is basically 11 inches by 7 inches by 5 inches tall. And I bought this on AliExpress for around $30, I think. It's not the most rugged box there is. Some enclosures, I'm pretty sure, are better with thicker walls and everything. But for $30, it will be rugged enough. I'm implementing bolts through inner plates and outer plates. That's going to give a good support to the electronics. Plus the electronics themselves are on a aluminum plate as well. The electronics are going to be raised. You can see all these standoffs all around. This keeps a gap, so the aluminum plate will not be touching the bottom. I've already pre-drilled all the positions for the mounting. This box is going to be mounted to the support arm for the feed point. So it's going to be good enough like that, as long as the support arm itself can support the weight, which should be the case. It's made of steel. All right, now for ventilation, I have found a strategy of an inlet and an outlet here. Inlet below on the side. I put some screens inside, aluminum mesh. Same thing on the outlet. The outlet is not complete here. What you don't see is a chimney that I will insert like this, and we'll just tape up to make sure that everything is watertight. And that chimney also has a grill, some mesh inside, and it's about, I'd say, 6 inches tall. And the intent, of course, is for the heat to rise during the summertime and create a draft, a natural draft, and the heat will come out here and will come in from the other end here. And this is 2-inch PVC pipes, and it's the type for vacuum cleaners in central vac. So it's rather thin. It's not a pressure pipe or anything, but it's got all the fittings I needed, plus I added some rings. Everything is glued with epoxy. I have some white epoxy glue, AB type, that I mix. It comes in jars and I have a lot of it. So it's all glued with white epoxy. Same thing here for this adapter. And inside I've added a fan, a blower, as you can see. It's a 50 by 50, so 5 centimeters by 5 centimeters by 15 thick. It's a 12-volt fan that I run on 10 volts, and this makes quite a difference. I can tell you, when this fan runs, I can feel the draft. No doubt about it, I can feel the draft. And whenever I transmit, the heatsink goes up in temperature, of course, so the aluminum plate, but the ambient air stays about the same. So the air circulation is sufficient so that the ambient air temperature inside the box stays about the same. So there is a cooling effect, no doubt about it. When I don't run the fan, of course the heatsink and the ambient air will go up in temperature, The chimney effect does work when you put your hand here and say the heatsink is about 50 C. If you put your hand, you can feel a bit of warmth, so warm air coming out just by natural convection. It would have been great to put a much longer chimney, which would have accelerated or increased the chimney effect. But then it's also adding to the wind, the load, and everything else. So I decided that in total of 6 to 8 inches of column will be good enough. And I had to add a bit of an elbow here to make sure that water doesn't go in. My intent is to shut off the outlet and the inlet with these plugs in the winter time. So I will climb in the fall time, plug the inlet, and tape it up, and then same thing for the outlet, so that there's no snowflakes or melting snow or anything that's going to get in. We don't need that ventilation in the winter time. It's only in the summer that we really need the ventilation. So I made these plugs, and it will be fine for winter time. Okay, as far as the connectorization, I've used these 6-pin SP13 type of connectors. I'm not sure exactly what they're used for, but they're IP68 watertight, and that's what I wanted. They're 6-pin. I could have picked as many as 8 pins, I believe, but 6 was going to be enough. One's for the connection down to the shack, one's for the actuator itself, and the third one is for the feed point, preamp, and the coaxial relay. And of course the IF port is right here, an SO239 that connects to a BNC inside, because I did use a BNC to SO239 adapter inside. For the other 3 types of connections, I've used DB9. You saw this on the electronics, so regular DB9s, and that works well. It gives a positive feedback when you connect them together and they stay together. I could even put tie wraps or screws to make sure they don't disconnect over time. Now, how does the electronic fit in there? Well, it fits very well. Actually, if you take the electronics like this and you hold the connectors like this, you can insert the whole plate inside just like that, and you're done basically. If you can keep all the wires out like I just did. The fan, so hook up the fan, hook up the 3 DB9 connectors, and hook up the RF BNC to the port, the adapter here for the in and out, the SO239, and you're done. Everything fits inside the enclosure very well. And the fan, even though it protrudes in the cover like this, you can see it fits like a glove, exactly where it should. Doesn't touch anything, allows me to close the lid, and will keep the enclosure cooler in the summer days when I'm operating. Of course, if I'm not operating, everything is shut off and there's no heat generated inside the box. It's just when I'm operating that we'll be running that fan, and only in the summertime, of course. So the box has 2 latches, and there's a padlock position as well. So I will definitely use the 2 latches, and we'll probably add a thumb screw here probably as an extra clamping force. And I may put some coaxial along this edge and this edge here. Not sure yet what I'm going to do. This box will be slightly inclined by about, I don't know, 10-15 degrees in this direction like this. So for the port, the outlet port, the position of the chimney is not really important. I will probably put it so that it protrudes outside of the box, above the dish basically, or I may decide to put it like this. I'm not sure yet. Doesn't really matter. So there you have it. The project is pretty much complete as far as the enclosure electronics go. Everything's tested and ready. What's left for me is the dish work. The actuator, make sure that everything is operational and that this box is fastened to the mounting arm for the feed point. And you're going to see this in a future video. All right, all for now. 7-3.